this is not my favorite way to do it, but it is an option and sometimes it works very well. I'm using the example of the equation 3x minus 5y equals 24. The first thing you should do if you're going to make a table is to set up a table with an x value, with the equation that you're using or the rule that you're using, and the y value that you're going to get as a result. So, step 1, you choose some x values. Step 2, you substitute them into the equation to find the corresponding y values. And step 3 is that you're going to graph the resulting points. I will do 3 different points on the graph. This is just the first one. So I picked x equals -2 at random. You choose the x values, you put them into the equation, and you figure out what the y value would need to be. So this -2 I picked. You could pick any number, but I picked -2. So I put -2 in where the x was in the equation. 3 times -2 gives me -6. So the rest of the equation just carries on. -6 minus 5y equals 24. I want to solve to get y by itself, so I added 6 to both sides of the equation. That leaves me with -5 equals 30. I needed to get y by itself. Right now it's being multiplied by -5, so I needed to divide by -5. Divided on both sides, and I solved, and I got y equals -6. So here it is, y is -6. So our first point on the graph that we're going to graph then is the point -2, 6. X is -2, y is 6. The next point that we're going to work with is that I selected x is 0. In this case, this does not turn out to be a very nice set of numbers at all, and that will happen. This is why it's not my favorite way of doing it. But I put the 0 in for the x. You can see here, 3 times 0 is 0, so nothing comes down. The -5y comes down, the equals 24 comes down. I need to get y by itself, so here it's being multiplied by -5. I'm going to divide by -5 to solve the equation. And when I do so, I get y is equal to -24 over 5. So y is -24 over 5. It's a fraction. It's not that easy to graph, but that's what you get when you do a table of values. The third point is where I chose x was 5. Again, I put 5 in for the x into the equation. 3 times 5 is 15. That comes down. Our -5y comes down, our equals 24 comes down. I have to again get y by itself, so right now it's being added with 15. I subtract 15 from both sides, and I get the -5y equals 9. I need to get the y by itself. It's being multiplied by -5, so I divide by it, and I get y equals -9/5. So my result is y is -9/5 when x is 5. I did tell you I don't like this method all that well because it doesn't always work so well, but there it is. So we have found 3 points on the graph, and now it's going to be our job to actually graph them. Now in order to graph them, we need to take those points that we picked. We had -2 on the x and -6 for the y. So I'm going to go ahead and mark a point at -2, -6 for the first point. Our second point was 0 and -24/5. It's easier to think about that in terms of a mixed number, so 0 and -4 and 4/5. So 0 on the x down 1, 2, 3, 4, and 4/5 is almost, but not quite, -5. Our last point is this 5 and -9/5. Again, I think it's easier to think of it in mixed terms. So 5 for the x, -1, and 4/5 for the y. So 5 on the x, 1, 2, 3, 4, 5, and -1. And 4/5 is almost, but not quite, the -2. So there's the graph of the 3 points. Now all that's left to do is to connect them. And so when we do that, we'll get the line of the graph. This equation is tricky because it does not cross the y-axis at a whole number, and it is a bit ugly to graph because of all of the fractions involved. But that is the equation of the line, and that is an option. You do not have to follow this particular option of graphing using a table of values. It's easier to use a table of values in other cases, but this is an option if you wish.